welcome you all in our today's advanced master class. Today we are going to study chapter 3, periodic properties of elements and chemical bonds, part 2. Basically we have discussed the periodic table section and up to P block in our first part, and in the second part we will be discussing a small remainder of P block as well as D and F block related extra informations that are available in our different writers book. I have to remind you that regarding those informations which are labeled as extra should be only studied after reading the main books. Main book information is more vital than this extra information, but some extra informations are very crucial, and I'm here to guide you which are really important and which you can avoid in your journey. Anyway, let's start our discussion. In the first slide, as we can see, regarding P block, there are some boiling point of inert gases. All of them are important? No. Do we have to remember all of them? No. What should we learn at least? I'm marking those as red. You should try to memorize the boiling point of helium, and you should have the idea that the boiling point gets increased from top to bottom, even though the digit gets lowered, but you have to remember there is a minus sign in front of them. So among the inert gases, which shows highest boiling point? In that case, the answer would be radon, and it is quite obvious because the immediate or the precedent group of group 18 shows the similar trend in terms of melting point or boiling point. As you know, from fluorine to iodine, we see the transition of gas to solid. That's how we can easily recall that all the nonmetals show a trend that is from top to bottom or in a group, the melting point or boiling point gets increased, and the numerical value which is important is for the helium. Anyway, let's move on to our next question. Here, a question appeared from our previous class, which or pair is incorrect below. So regarding this, if we don't know about anything, let me show you some tricks so that we can easily recollect those. When you say appetite, you should not think about something that fills up your stomach. You should think about phosphorus. It's not appetite, it's appetite. That's why it is correct. Again, feldspar, usually feldspar contain potassium, aluminium, but it does not carry the nitrogen. On the other hand, porcelain can carry silicon. The formula of porcelain, it is basically mullite and cristobalite mixture, which is basically silicate, aluminum silicates. So A and C are correct, but the feldspar is not correct. Here potassium is there, aluminum is there, but no nitrogen is available in case of feldspar. What is feldspar? It is basically a fluxing agent. Fluxing agent is something that helps to reduce the boiling point or the melting point of a certain mixture. Anyway, our correct answer here is feldspar, which is nitrogen. Which one is not the characteristic of graphite? We know graphite stays in a hexagonal pattern, and also it shows sp2 hybridization, but melting point is 3730 degrees Celsius, and it works as an insulator. No, it works as an electrical conductor. Now they are asking about which one is not the characteristics. Basically the question should be which one is the characteristic of the graphite, because of all of them, B, C and D are not the characteristic of graphite. So regarding the question, if we think that the question is correct, then the answer would be B, C and D. All of them are correct. Why? Because the melting point would be 3730 degree Celsius, and instead of sp2 it would be sp, instead of sp3 it would be sp2. Because of the sp2 hybridization, it shows the electrical conductivity. Once it becomes electrical conductor, it will not act as an insulator. So electrical good conductor, graphite. So if it is a wrong question, then the answer would have been hexagonal, because which one is correct? Only hexagonal would be correct for the graphite. Anyway, nature of aqueous solution of aluminium. Aluminium produces aluminum hydroxide, and regarding aluminum hydroxide, as we can see, not aluminum hydroxide, not only aluminum hydroxide but also aluminum oxide. These are aluminum oxide actually acts as a amphoteric oxide. Amphoteric, it is neither neutral nor acidic nor basic. Basically it acts as a amphoteric. That's why the answer would be D, acidic and basic. So it can also be stated as amphoteric. Anyway, if regarding neutral oxides, let me remind you the mnemonic co no pani nai. With this mnemonic we can easily recall all the neutral oxides. Anyway, which one is metal? Very easy question. I think potassium is a known metal to all. Also indium and thallium, those are present in the group 13, are also included in the metallic group. So the answer would be all of the above. Which one is acidic oxide? We know nitrogen have 5 oxides, and about those 5 oxides some other informations are very important for admission test. Now let me remind you, nitrous oxide is also known as laughing gas, and it is a neutral oxide. On the other hand, dinitrogen trioxide, this is basically a acidic oxide. This is called nitrous anhydride. This is called nitrous anhydride, and this is the acidic oxide. So we got our answer, which is option B. And regarding the nitric oxide, this acts as a vasodilator, which dilates the vessel, and also it is a neutral oxide. So the correct answer is B. Now we have come to D block. As we all know, D block got 41 elements, and most of them, in fact all of them, are metals, but not all of them are transitions. Transition metals are those in which stable ion shows electron in their d orbital. That's how they show some specific characteristics to become a transition metal, such as catalytic property, variation in oxidation state, also having the ability to form complex compounds as well as colorful compounds, and magnetic property, which is paramagnetic mostly. So these are the 5 unique properties that are responsible for labeling a metal as transition metal. And moreover, we should know some regarding some metal alloys. These are also available in our Hajari Sir book. It is not like only available in Go Sir book. This is also present in Hajari Sir book, but there may be discrepancy or dissimilarity regarding the percentage. Anyway, let me guide you through this. In case of brass, the constituents are copper and zinc. So we remember this with using a Bangla mnemonic. You should say that Kaziner brush. Kaziner brush. So regarding Kaziner brush, we can easily recall brass is composed of copper and zinc, and mostly it is copper. On the other hand, regarding the bronze in Bangla it is kasha. In Bangla it is kasha. So kasha would guide you to recall copper and stannum. Lastly, a very important alloy is duralumin. This is a very important alloy. Why? Because it is used in preparing the aeroplane body. What we see about airplane is the body. We barely see the engine and all. We only see the body whenever we think about aeroplane, and it should be light, and it should not be so light that it breaks down in the air. So malleable yet strong alloy should be required for building such an aircraft, and that's where duralumin comes to play. So duralumin is composed of aluminium, copper, magnesium, manganese, iron, silicon. So regarding this, you should remember or memorize all of the metals that are present within the duralumin. Okay, so let me guide you how to recall all the all the metals that is present within the duralumin. See, the name is duralumin, so it will certainly have maximum amount of aluminium, and it is almost 95%. Okay, and as you can see, there are some mean, and regarding mean, you should remember the manganese. And also there is magnesium. And what are the other things that may be found in duralumin? You see, any metallic thing, whenever something metallic comes out, we think about iron. So iron should also be there. Should also be there. So duralumin cafe, we should say duralumin cafe, not cafe. It would sound like kufe. And regarding ku, it is copper, and regarding fe, it is iron. And the remaining portion is silicon. Anything digital, anything advanced should not be without silicon. Without silicon, the transition to digital wires would not be possible. Our today's digital world is solely dependent on a semi-metal, which is silicon. Without silicon, it would not have been possible to organize such a class where you can see the record in your home, in your mobile, or in your laptop. So silicon should also be there in duralumin. Anyway, that's how you can recall. One thing you should remember through this trick, this is not something a difficult trick to remember, but if you spend such time on a single topic, then you may find that it is easily memorized even without a mnemonic. Only you need to spend time. Sometimes you are wondering that where is that time? But actually there is time. There are some time where you are scrolling in your mobile phone or doing something else. Try to avoid those, cut off those in the upcoming 3 or 4 months, and you will get the result. Be sure about that. Now regarding d block elements. Common properties of d block elements are already mentioned in our main writer's book, which is Hajari Sir, but here some other information are there. It is said that the change in ionization energy of the elements in d block is very low, because they are very close to each other. Basically, they are very close to each other, and they form both ionic and covalent compound. They form complex salts. These are the properties of transition elements. The reason of the change, of the narrow change in the ionization energy, is the small size of their atoms or ions, and also they do show some high nuclear charge, and the presence of d orbital is also responsible for this property. So we should know that the change in the ionization energy is very negligible. I mean, iron, cobalt, nickel, these are adjacent to each other. In p block and s block, the adjacent metals show much difference in ionization energy, but due to similarity in their property and the presence of d orbital, the change is very narrow. Anyway, regarding chemical characteristics of d block element, you should know that they form complex compound, and one important example should be Fehling solution. Fehling solution is a very crucial reagent with which we can differentiate aldehyde and ketone. You know, Fehling's solution reacts with aldehyde to generate a red precipitate of copper oxide. And regarding Fehling solution, you should also know that another version of Fehling solution can be called as Benedict reagent, which is used to determine the presence of reducing sugar in the urine sample of any diabetic patient, and that reducing sugar is glucose. Anyway, that is discussed in our botany section in cell chemistry. But in here, we only see that Fehling solution is a complex compound of copper, and also similar reagent which is used for differentiating aldehyde and ketone is also known as Stalin reagent, which is composed of silver. Complex ion formation of transition metals are responsible for incomplete d orbital. Basically, why complex ion is formed? Because of incomplete d orbital, where the ligands can donate the electron, and the small size of cations will give them higher charge density and higher ability to attract those electrons, and also coordination number and oxidation number. Coordination number and oxidation number related information should be also remembered regarding the complex ion formation. You should know that all the complex ion shows equal coordination number equal to their ligand number. Anyway, let's move on to the next slide. Okay, regarding d block colors of transition metal ions, there is always some doubts to every student. How can we remember all of this, and is it really important to memorize all of this? Certainly, I would say that it is not very much important, but sometimes question may appear from this section because it is very visible in the book. If you go through your book, you will find that there is a complete page full of such information, and that's where teacher may fall into the trap and arrange the question from this section. And regarding the color, Let me give you a mnemonic. It may sound a bit odd, but trust me, it works. It works if you take it sincerely. If you think something such as very foolish or very odd, it would remind you in that way because it is odd. You should know that something very attractive or very peculiar always gets caught in our mind. That's how our brain works. So we should have to find a very effective or a very least effective one, so that in both way it can trigger our brain differently. Anyway, regarding the colors, I will provide you a Bangla mnemonic with which we can remember the colors. ফেনীর সবুজ ভাই, ফেনীর সবুজ ভাই, ফেনীর সবুজ ভাই. See, ফেনীর সবুজ ভাই, with that we meant, what did we mean? We mean iron. Where it is? Here it is. Ferrous. Ferrous is green, and also nickel 2 plus is green, and also vanadium 3 plus is green. See, iron 2 plus, nickel 2 plus, vanadium 3 plus. ফেনীর সবুজ ভাই, তার 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 বেগুনি, তার বেগুনি কারে, তার বেগুনি কারে, কারে manager, manager, তার বেগুনি কারে manager. This is a whole sentence. I'm just separating the segments to making you realize the mnemonic, and after that I will cover that in a whole. ফেনীর সবুজ ভাই তার বেগুনি কারে manager. And regarding this, let me show you. Titanium can be purple, right? Purple sounds like a violet. Again, manager, so Mn3 plus, which is violet. Beguni kar, so again chromium 3 plus reminds us regarding violet. So what are those? I think it would be visible. So regarding titanium 3 plus, chromium 3 plus, manganese 3 plus, these are violet. Anyone else violet? No. Now কবির ভাইকে নিয়ে, কবির ভাইকে নিয়ে ফেনীর সবুজ ভাই তার বেগুনি কারে ম্যানেজার কবির ভাইকে নিয়ে. So regarding কবির ভাই, let's find out what are those. Copper 2 plus is blue. Again, which one else is blue? Vanadium 4 plus. Vanadium 4 plus is blue. So it is copper 2 plus, it is vanadium 4 plus, and by niye we meant Nil. So all of them, these are the color. These are the colors. Okay. কবির ভাইকে নিয়ে, lastly কেমনে গেল. With কেমনে we should remember cobalt 2 plus and manganese 2 plus. Cobalt 2 plus and manganese 2 plus. With gelo we remember golapi in Bangla and pink in English. So almost all of them are found in this mnemonic. Let me repeat this once again. ফেনীর সবুজ ভাই তার বেগুনি কারে ম্যানেজার কবির ভাইকে নিয়ে কেমনে গেল. With this mnemonic you can recall all the colors. You may be wondering that where is ferric and where is zinc. Regarding zinc, you should know that it is not a transition metal, and all of the agents or metals which are not transition will form colorless compound. Only the transition metals are responsible for colorful compounds because of that crystal field effect. And ferric is a very known cation whose color is light brown. It is very known to us. So without any mnemonic you can recall it. Ferrous green, ferric brown. Ferrous green, ferric brown. You should remember that out of nowhere. Without mnemonic you should be able to recall ferrous and ferric. Anyway, I think with this mnemonic you should try to write it down first, and you should try to write it down in the definite area of that book where all of the colors are written. There are some other colors of compounds, but you should only focus on the ions because these are more prone to admission test. Anyway, let's move on to our next slide. Here we get some information regarding complex compounds. What can be found in our admission test regarding complex compound? In complex compound, we may get questions regarding the hybridization. We may find questions regarding the shape of the compound as well as the coordination number of the compound. So let's see. If the coordination number is 2, then the ligand number should also be 2. Basically, ligand number is equal to coordination number. If you do not know that yet, you should learn it right now. Ligand number is equal to coordination number. Okay, so the number of ligand will guide you to find out the coordination number, and this coordination number is equal to number of hybrid orbital. So it will also help you to find out the hybridization. See, there are 2 ligands, so the number of hybrid orbital would be also 2, and that's how the hybridization becomes sp. Again, for this, as you can see, the number of ligand is 3, so it would be sp2. Sometimes the number of ligand will not act very easily to find out the hybridization, such as here is 4, so sp3, but here is 4, it is not sp3, instead it is sp2d or dsp2. Which one can be correct? Regarding this, I should remind you that when some exceptions are there where instead of participation of all the p orbital, d orbital of preceding shell or the post d orbital, I mean the similar shell, that is 3d or 4d shell, comes to participate in hybridization because of an effect which is called John-Taylor effect. But we should not understand the mechanism of that effect, but we should only focus on the examples of those exceptions, such as tetracyanonickel. In case of tetracyanonickel, cyanide is a very strong ligand. That's why it will repel, or it will compel the electrons of the 3d subshell to move ahead and make one orbital empty, and that empty orbital will participate in hybridization, and thus the hybridization will be dsp2. You should know that dsp2 and sp2d are not similar. When the ligand is strong, then the preceding d shell would participate, and on the other hand, when the ligand is weak, then the d shell that comes after will come to participate in hybridization. So regarding the shape, since all of the p orbitals are located or distributed along 3 different axes, when all the p orbitals participate, then a 3-dimensional shape is obtained. But if all of them are failed to participate, then we will get a planar structure. That's why sp2d or dsp2 would always show a square planar structure of the lattice. Now, regarding the properties of also their magnetic property, you should know that all of them are mostly diamagnetic. Which are paramagnetic? As for example, tetrachlorocobalt. And again here, tetrachloro. These are paramagnetic ones. So regarding paramagnetic, I think it would be easier or wiser to remember the chloride version. When you get chlorine as the ligand, you will say that these are paramagnetic, and remaining complex ions act as a diamagnetic one. Anyway, since all of them show 4 ligands, that's why the hybridization would be sp3 and the structure would be tetrahedral. Now, tetraamino nickel or tetraamine, nickel tetraamine, regarding that it is dsp2 because of the strength of the ammonia, and it becomes square planar as well. And tetracarbonyl iron shows dsp3 hybridization instead of sp3d hybridization because of the strength of carbonyl. There is only an exception, which is tetracarbonyl nickel. Here it should have been dsp2. But instead it is shown as sp3. It is an exception. Carbonyl is a very strong ligand. Even after being a strong ligand, tetracarbonyl nickel shows sp3 hybridization. This is an exception. Apart from that, and all of the remaining examples can be explained easily. So I have already marked what are important from this section. Now let's move on to our next slide. Now, coordination number of various transition metals can be easily remembered. This is basically relevant to their charge as well, but not all the cases. Like silver, it is 2, but for copper, zinc, nickel, cadmium, it is 4. As you can see, the number of ligands are the coordination number. So it would be very easy for you if you go through our previous chart again. Then you will find that it can be easily remembered. If you only read the names of all the complex ions, then you will get an idea what coordination number can be possible for which metal. So I think I advise you to remember the 2 and 4, and all of them, the rest of the metals would show 6 coordination number. Now, regarding the metallic oxides in colorful glass, and we should know that pink glass should have manganese oxide. This is very important. Okay, and all the rest glasses are not very important. Only important is pink glass, manganese oxide. But you can remember those. You should remember that cobalt ion shows pink color, but cobalt oxide is blue. Again, ferric shows brown or yellow. Again, ferric oxide is also yellow. Nickel, you see the nickel ion shows green color, but the nickel oxide is brown. Anyway, so our mnemonic will contradict with this chart. We should know that is about the ions, and this is about the compounds that are present within the glass. You should only focus on the manganese oxide. Now, regarding the determination of complementary color, how complex ion becomes colorful, or the compounds of compounds of the transition elements are colorful, because when the electron jumps from lower energy shell orbitals from higher energy orbital from T to G to Eg, that transition results into absorption of some wave, and the visible spectrum, the wave corresponds to the visible spectrum, and the remainder or the complementary spectrum is visible at that moment. So when violet colors gets absorbed, yellow color gets visible. When indigo gets absorbed, orange is visible. When green is absorbed, red is visible. Now here, as you can see, we can easily remember with a color wheel. How? We should only use that VIGYOR. Basically, we have removed what? We have removed the blue version. We have removed the blue. Basically, we have to remove the blue version, blue, or in Bangla, which is Asmani. If we remove that, we can get the color wheel correct, and easily we can remember the absorbed color according to the color wheel. Suppose for absorption of violet, we will get yellow. For absorption of red, we will get green. For absorption of orange, we will get indigo. That's how it works. Now, regarding the ligands, there are some types of ligands on the basis of their charge, which is charge neutral, positive, negative. Positive and negatives can be easily understood with the charge. The neutral ligands, you can go through a reading, and I think you should not have to remember or memorize everything. Just go through it for once. You should know that according to charge, ligands can be of 3 types. Regarding the free electron pair and the coordination bond, 6 types of ligands are there. Which can form one bond, it is monovalent. Which can form 2 lone pair electron, it is bivalent. You have to remember the examples of the bivalent ligand. It is ethylene diamine. Again, we have to go for hexavalent, which is ethylene diamine tetraacetate. These are the important examples only. Which one is not a characteristic of D block? Characteristic of D block should be related to the metals. Metals are solid and malleable, so it is a characteristics. Ionization potential less than P block, certainly, because P block stays at the right side of the periodic table, so it would show a higher ionization energy. Ignites fire when reacts with water, good conductor. Basically, D block elements are not that reactive that it reacts with water to form fire. It happens for sodium, which is a group 1 element or S block element. Which one is the composition of brass? With brass, we meant Kazin and brass. So with Kazin, copper and zinc, and the percentage here should be 65 and 35, so which is 63 and 37. And option B was bronze, which is in Bangla, Kasha. Which characteristic doesn't indicate transition metal? Transition metals form complex compound, shows variation in oxidation number, and shows tendency to form colorful compound, and also possess incomplete d orbital. So regarding invariable oxidation number, it would be incorrect. It should be variable oxidation number. It should be variable oxidation number. The answer would be B. Now, for F block elements, we have to know that there are 27 elements, but we know all of the F block elements are within a group which is known as inner transition element. But the number of inner transition element is 28. The number of inner transition element is 28. How it became 28? We have 27 F block, and along with that we have to add thorium. Along with thorium and 27 F block elements, altogether we get 28, and this is the number of inner transition metal. This inner transition metal is a very important for MCQ. Period 6, 7 and group 3 elements, where they are located in period 6 and 7 and along the group 3. Group 3 is the largest group of our periodic table in terms of the constituents or the residents, which is 32 elements. And apart from in group 3 there are 32 elements, and in group 3 if we avoid those two elements, above, which is scandium and yttrium, remainder 2 would fall under 2 different series, which are lanthanide series and actinide series. Lanthanide series is composed of 15 elements. You may be getting questions like which metal is not included in F block but present in lanthanide series, which is lanthanum. Again, from actinide series, actinium and thorium, these are D block elements. These are D block. All of the remainder elements are F block elements. Also, lanthanide series is known as rare earth metals. There are some 4F series and 5F series classification. 4F series basically present in period 6. And 5F series is present within the period 7. So 6th period F block elements are included in the 4F series, and 7th period F block elements are within the 5F series. What are the trans-uranium elements? Trans-uranium elements are neptunium to lawrencium. There are 11 elements which are trans-uranium, and these are synthesized, not found in the ores or anywhere. Lanthanide series, another name can be rare earth metal. This is very important for medical admission test, and the number of members are present. The group 3 and period 6 are called lanthanide series. And you should also know that rare earth metal is not only confined to lanthanide series but also includes scandium and yttrium. Including that scandium, yttrium and the 15 lanthanides, the total number of 17 elements are there to be called as rare earth metal. So if you have any questions regarding the number of rare earth metal, the answer would be 17. And what are the elements of lanthanide series? We do not have to remember all, but we should only remember that from lanthanum to lutetium, we have what? We have the lanthanide elements. We can remember the boundaries. After lanthanum, the F block starts with cerium. From cerium, F block starts. So basically, it is the first F block element. First element of F block is cerium. Up to lutetium. Cerium is the 25th most abundant element of the world. Which is the most abundant element of the world? The answer will be oxygen. The 25th most abundant element is the first F block element. Only promethium is radioactive in lanthanide series. This is also important. Basically, lanthanide series are not radioactive. Only promethium is radioactive. On the other hand, the actinoids are all radioactive. Lanthanide are found in monazite ore, which is thorium oxide. And regarding the electronic configuration, as you can see, it is here the period is 6. So that's how it became 4F series. 6 minus 2, which is 4F. Lanthanide series property, you should know that ionization energy is lower than the ionization energy of D block. Why? Because they are located in group 3, and D block does have group 3 to group 12 elements. So it would be, we have to go right to find the D blocks where the ionization energy will certainly increase. There are some important information regarding the diamagnetic elements. Lalu, Kano ekhane. With this, we can easily remember. Anyway, these are diamagnetic, you can remember those, and the other lanthanides are paramagnetic. Such informations may come easily in our admission test. And regarding use, they are also being used in catalytic converter. In catalytic converter, as we know, there are platinum or vanadium pentoxide, but also moreover there can be thorium oxide as well in catalytic converter. Petroleum refining, science technology, and one important information regarding gadolinium, that it is its contrast is used within the MRI technology. So these are the information that is important regarding lanthanide series. Now about actinide series, we should know that thoria and ceria. Basically ceria is not a compound of actinide series, it is a compound of lanthanide series. It is a lanthanide element, yet it is mentioned in the actinide series section. Here these two are used in headlight of car and searchlight of ship and train. So basically it helps to brighten the light. Moreover, americium is a metal that is actinide, and it is used in the treatment of cancer. On the other hand, uranium, we all know about uranium. We also know about the isotopes of uranium, which are used in nuclear reactor as well as generating the nuclear bomb. Special information regarding periodic property. As we all know, these are the informations that we have already discussed in our main book. Basically, these are not something very different. There are some exceptions, but it is written in a more organized fashion than the Hajavisar book. As we all know, ionization energy shows increase in the period from left to right, and it decreases from top to down. But there are some exception in the period. There is no exception in the group, but there is some exception in the period, where basically in p block. Why? Because of the stable electronic configuration. Stable electronic configuration shows or compels them to show a bit higher ionization energy than the precedent or the afterward element. Anyway, it is expressed by EI. This is very important. EI will always be positive because ionization energy will be positive, but the electron affinity will always be negative. And ionization potential is a endothermic process. It should not be exothermic, it should be endothermic, because endothermic is responsible for the positive change in the enthalpy. When the electronic configuration of an atom contains half filled or full filled degenerate orbital, it is more stable. See, these are the terms that you have to remember. If it is half filled or full filled degenerate orbitals, then it is more stable. And for this reason, as we can see, boron, if we can, ionization energy of boron is less than that of beryllium. So we can write it down this way: beryllium greater than boron. First ionization potential of sulfur is less than that of phosphorus. Basically, I can remember all the exceptions using a mnemonic. Let me teach you that. With this, how did I remember all this? With a mnemonic. The mnemonic in Bangla would be Babir Noya Manager Alom Police Station. See, baby, beryllium more than boron. Noya, nitrogen more than oxygen. Manager alum, so magnesium more than aluminium. Polish station, phosphorus more than sulfur. With this, we can remember all the exceptions that are present here. Okay, I think you don't have to read anything else. With this, we can remember. Now, regarding electronegativity of fluorine is the highest, which is 4, and this is called Pauling scale. According to Pauling scale, electronegativity of elements of the second period, we should only remember about carbon, nitrogen, oxygen, and fluorine. These are really important. Value of electronegativity can also be determined using Mulliken scale. Mulliken, we heard about it regarding the oil drop experiment with which we determine the electron charge. Again, Mulliken is heard of determining the value of the Avogadro number. And this is only applicable, but regarding electronegativity, this is only applicable in case of univalent elements. So if the valency becomes double, it will not be possible to determine the electronegativity. Value of electronegativity in Mulliken scale is 2.8 times more than that of Pauling scale. So lithium would show electronegativity of 2.8 in Mulliken scale, while it is 1 in Pauling scale. Anyway, size of atom, as we know, from the left to right, the size of atom gets decreased. Why? Because the shell does not increase, but the electron numbers get increased. So the force of attraction between the nucleus and the electron gets increased. Hence, the force will compel to shorten the radius. Anyway, here we have to know the atomic radius of helium is 31 picometer. On the other hand, francium, which is at the bottom of that group, shows higher radius, which is 348 picometer. And you should also know that the largest atomic radius is of francium, which is 348 picometer. This is the largest. And helium is not included in the same group. Hydrogen and francium is within the same group. Anyway, here it is mentioned because it is the lowest. Helium is mentioned because helium shows the lowest atomic radius and francium shows the highest atomic radius. We have to remember these two information. One is 31 and another is 348 picometer. So considering size of molecule, regarding the size of molecule, the giant molecule can be sulfur. Basically, it forms with, carbon can form far more giant molecule than S8, but we are talking about those molecules which participates in reaction. So in terms of that, S8 is the largest one, but you may be thinking about graphite or diamond. Those do not easily participate in reaction. That's why they are a bit different. The boiling point of sulfur is 445 degrees Celsius. On the other hand, the lowest boiling point was shown by argon here. Anyway, regarding melting and boiling point, there are some trend, as you know, in the metallic group. In metallic groups, we see from top to bottom, boiling point, melting point gets lower. But in the non-metallic groups, from top to bottom, melting point, boiling point gets higher. See, lithium shows the highest melting point and cesium to some extent liquid at room temperature. On the other hand, about halogen, you can see that astatine is solid while fluorine is gas. As the atomic number increases, the melting and boiling points of elements in the same period do not change continuously. This is also important that melting point and boiling point is not a periodic property. It rather follows trend in the group, but it does not show any trend in period. Regarding the electronegativity, you should learn that iron shows 1.8 when the charge gets increased, so electron is removed, so it would certainly compel more attraction. It will certainly increase more pulling of electrons because of its high charge. So it should be 1.83, and for ferric it should be 1.96. As we all know, what is electronegativity? Electronegativity is the tendency to pull the shared pair of electron in a covalent bond. So once the charge gets increased, it would certainly cause more increase in electronegativity. And regarding the alkane, you should know that alkane shows the least electronegativity, while the alkene carbon shows a bit higher electronegativity, and the alkyne shows the highest electronegativity, which is 3.24. And the hybridization is known to us. Diagonal relationship is something that is found in the periodic table, that in some second and third period, in the elements of second and third period, not all the periods, in the elements of second and third period, the elements that are placed diagonally to each other show similar trends in characteristics, such as lithium and magnesium, both are metals, and both of them reacts in the same pattern. Also, there are similarity between beryllium and aluminium, also boron and silicon. In what criteria we find similarity? Size of atom, electronegativity, and polarization ability. These are the similarity that we usually found in diagonal relationship. How can we remember this, the diagonal relationships? With this formula: Limar, Biral, Bashai. Limar, Biral, Bashai with Li, lithium, Ma, magnesium, beryllium, aluminium, Bashai, boron, silicon. So Limar, Biral, Bashai. With this we can remember the diagonal relationships. Anyway, regarding the chart of pH according to their color, we should know that 7 stands for neutral pH, and the color becomes green. So green is the color of neutrality, is it? Basically neutral color should be white, but here it is mentioned as green, so we should remember the green. And the orange color or yellow color would be found for a bit acidic solution. On the other hand, for a pH less than 3, we will get red color. For blue color, we will get a pH of 8 to 11, and for purple color, we will get a pH of more than 11. Okay, this is something that we have to memorize. There are no such trick to remember all these numbers and the formula. We have to just read it in a way so that it can be remembered as a photographic memory. Now, there are some oxides as well as their color and pH. As you know, all the non-metallic oxides, you should know about this. Non-metallic oxides, acidic. On the other hand, metallic oxides, basic. And some metal as well as semi-metal oxides can be amphoteric. Okay. Now, if we know about this, we can easily guess that the non-metallic oxide would show red color. Again, as we know, water is a neutral oxide, so it would show green color. And calcium oxide, sodium hydroxide, it would show different color because of their basicity. It would show blue color. On the other hand, sodium suboxide would show purple color. Anyway, with this we can remember the pH range of such compounds. Now, there are some questions which is incorrect about ionization potential. It is an endothermic reaction, this is true. Ionization potential of S block is less. Certainly S block would show the least ionization energy. Ionization potential decreases from left to right. No, ionization potential increases from left to right. So here the answer will be increase, not decrease. Ionization potential of nonmetals are normally higher, true. Which has the lowest electronegativity? The lowest electronegativity would be shown by the element which is placed at the leftmost side. As we know, in the second period, Li, Be, B, C, N, O, that's how the element goes. As you see, beryllium is placed at the leftmost corner. That's why beryllium would show the least electronegativity or the lowest electronegativity. Which one has the highest electronegativity? Highest electronegativity would be shown by ethine, not ethane. Ethine would show the highest electronegativity. It is around 3 point something. Which one doesn't decrease from above downwards? From top to bottom in periodic table, which does not decrease. Let's see. Melting point gets decreased for metal. Ionization energy gets lower. Electronegativity gets lower. Oxidation number does not change in a group. So the answer will be D. Oxidation number does not change within a group. It changes within the period. So with this,